The birds outside our windows are here because one side of this ancient crime scene survived. 120 million years ago, a quiet lake in China became a killing ground. Clusters of crushed bird bones packed together like owl pellets. Something had been feeding on them, repeatedly and systematically. But there was one problem. There was no predator, no skull, no teeth, no nothing. Just the victims. Almost like a killer who knew how to leave no trace. Until scientists found a single piece of the predator's body, and that one piece was enough to point toward the animal that may have been hunting those early birds. First, let's have a look at the evidence. Northwestern China. Changma Basin. Today is dry rock and fossil beds, but in the early Cretaceous, roughly 120 million years ago, this was a lake system and it was packed with birds. Paleontologists have recovered more than 100 early bird fossils from this one site. The most famous is changmaensis, a near-modern bird with webbed feet and a body built for water. But scattered among those birds were weird, broken clusters of bones. No clean skeletons, just crushed pieces, compressed together like pellets coughed up by modern owls after they swallow prey and eject the bones. That means one thing. Something was feeding here, but there was a problem. For years, scientists had the victim, but no predator. Then Jian changmaensis appeared. It wasn't what they expected. A carnivorous, non-avian dinosaur. And so far, it is the only non-avian dinosaur known from this bird-dominated fossil bed. They finally had a suspect for the crimes. Predators are usually the missing half of the fossil ecosystem. Changma is different because it gives us a repeated pattern. Many birds, damaged bird bones, and then one animal big enough and carnivorous enough to explain the damage. After the suspect comes the investigation. Jian was not found as a complete skeleton. The fossil is cataloged as GSGM D050, and what the team had was one shoulder, upper arm, and lower arm, embedded in yellowish-gray mudstone. The preserved bones included scapulocoracoid, humerus, the radius, and the ulna. The hand and the rest of the body was missing, but the bones that remained were still connected enough to show this was one animal and not random pieces washed together. After anatomy and measurements comes imaging. They photographed the fossil. They made interpretive line drawings. Then they used microcomputed laminography, a scanning method useful for flattened fossils, to look through selected parts of the specimen. They did 3 separate scans, one through the shoulder socket region, one through the elbow, and one through the distal radius and ulna. That let them see details hidden inside the slab. The glenoid, where the arm met the shoulder, the internal cavities of the radius and ulna, the shape of the elbow joint, and a strange foramen, a small opening on the proximal radius. But this creates the real problem. How do you name a dinosaur from only an arm? Because if you were wrong, you have not discovered a predator, you have just renamed somebody else's broken fossils. So the team compared every preserved bone against other dromaeosaurs. Microraptor, sight.The, Wulong, Tianiraptor, Zhongjianosaurus, and others. They were not looking for one cool feature, they were looking for a pattern. And the pattern started in the shoulder. The surface texture looked smooth and finished, which told the researchers this was probably a mature or nearly mature animal, not a juvenile whose bones had not finished growing. Then comes the caracoid. In Jian, the caracoid was unusually long compared with humerus. The humerus was 101.6 millimeters. The caracoid was about 37 millimeters, roughly 36% of the humerus length. In the paper, that proportion is one of the features that helps separate Jian from other microraptors. But the biggest clue was the hole. The caracoid had a large elliptical opening called the supracoracoid fenestra. In Jian, the opening was 18.6 millimeters long, almost half the length of the caracoid itself, and the edges were smooth finished bones, which matters because it means this was not just damage, not a crack, not a crushed ancient from fossilization. It was real anatomy. That opening is extremely rare outside microraptors, so when the team saw it, they were not just looking at a shoulder, they were looking at a microraptorine signal. Then they cracked the rest of the arm. The distal condyles of the humerus were developed on the cranial surface. The radius had that well-developed foramen near its upper end. The ulna was proportionally long. The specimen was medium-sized, bigger than some tiny microraptorines, smaller than the giants like Changma and Tyrannoraptor. Piece by piece, it stopped looking like a bird, and it became something new. This is how Jian, changmaensis, was named. Not from a dramatic skull, not from full skeleton, from a forensic anatomy case built out of shoulder proportions, arm measurement, scan slices, bone maturity, and comparison against the entire Microraptor family. The genus name Jian comes from Jian, a one-winged bird in Chinese mythology. That name fits both the bird-like nature of the animal and the strange fact that its holotype is basically one side of the wing and shoulder system. The specimen name, changmaensis, points to Changma, the place where fossil was found. So the name itself is a map. Jian, the winged creature, changmaensis, from Changma. And with that, one partial arm became the first named non-avian dinosaur from a fossil bed dominated by early birds. But there was still a problem. Everything at Changma was circumstantial. The crushed bird bones, the huge number of bird fossils, even Jiang itself. They all pointed in the same direction, but none of them actually proved this dinosaur ate birds. To convict a predator, paleontologists look for something much harder to argue with: stomach content. Because teeth can suggest a diet, claws can hint at a hunting style, but prey sealed inside a predator's body leaves almost no room for debate. And eventually, they found exactly that. Not in Jian, but in one of the closest relatives. In 2011, researchers described a Microraptor gui fossil from the Jehu biota with the remains of a bird preserved inside its abdomen, wing bones, foot bones, an entire meal frozen in time. That discovery changed how paleontologists view the whole group. If one Microraptor was unquestionably eating birds, then Jiang suddenly fit a much larger pattern. Now the Changma evidence wasn't standing alone anymore. The crushed pellets, the hundreds of bird fossils, the only large carnivorous Microraptorine in the ecosystem. Individually, each clue leaves room for doubt. Together, they all tell a remarkably consistent story. Not proof like a security camera, but the kind of forensic case paleontology is built on. Now that we've proved it's a predator, let's go talk about the prey. Gansus humanensis was not just a helpless bird sitting on a branch. It was one of the earliest near-modern birds, and its body points toward an aquatic lifestyle. The specimens preserve features like feathers and webbed feet. Its legs and feet suggest it has spent serious time in water, more like a duck than a songbird. Researchers have argued it could probably take off from water. That makes the hunt harder to imagine. How does a four-winged dinosaur can catch a bird that can swim, dive, and launch from the lake surface? The answer may be ambush. Picture the lake edge: reeds, low branches, muddy banks, birds feeding in the shallows. A glider does not need to outfly a bird in open air. It only needs one clean drop before the prey is airborne. The fossil bed comes cinematic, but still evidence-based. Jian above, Gansus below. Crushed bird bones left behind. A Cretaceous ecosystem. Let's talk about the family tree of Jian. Birds are dinosaurs. More specifically, modern birds are the only dinosaur lineage that survives today. Dromaeosaurs, the group that includes Velociraptor, Microraptor, and Jian, were close relatives of the bird lineage. And that is what makes this fossil so sharp. At Changma, the boundary between bird and dinosaur stops feeling clean. The birds had feathers. The raptors had feathers. The birds had wings. The raptor had 4 wings. The birds were part of the lineage that would survive the asteroid. The raptor belonged to the one that would disappear. For millions of years, these groups lived side by side, sometimes in the same forests, sometimes around the same lakes, sometimes as predator and prey. Jian is not just a new species. It is a snapshot of the world before the modern sky existed. A world where bird-like dinosaurs hunted dinosaur-like birds, and the future was not obvious yet. The animal eating the birds looked almost like a failed version of the thing that would inherit the sky. The most remarkable thing about Jian was not its size, because it wasn't a giant predator. It wasn't the biggest raptor that ever lived. What made it important was where it fit. For years, paleontologists had the victims, hundreds of early bird fossils and strange clusters of crushed bones. Something was hunting these birds, living in the same ecosystem and almost perfectly built to hunt among the trees. There's something almost ironic about that. One branch of the family bird tree was hunting another, but only one lineage made it. Jian disappeared millions of years ago. Its prey didn't. Every sparrow, crow, eagle, duck, pigeon, even the chicken in your backyard belongs to the lineage that survived. That's what makes this fossil more than just another new species. It tells us that microraptor-like dinosaurs weren't limited to its famous J-hole ecosystem. They were spread across different environments where early birds and their dinosaur relatives were competing, hunting, and evolving side by side. The next time you see a bird disappear into the trees, remember, its ancestors weren't just learning to fly. They were learning how to survive. If you enjoyed this fossil cold case, subscribe, and let me know in the comments which extinct predator should be put on trial next.